Hello, welcome to the Punctibyte for this fine February day, the 9th of February. I'm joining you today from Aspen, where we had our ski race. Today was the classic race, and then tomorrow is their long point-to-point 21K skate race, so it should be fun times. Time marches along, and we find ourselves looking at a whole new week of scheduling. This week we'll be doing labs 6 and 7 for most of you. T and Elias lab will be going on to lab 8. So we have a lot of excitement planned for the week, and it looks to be that Callie, Carl, and Anna are taking charge of Open Lab this Friday. So we'll be excited to see you there. And we'll be working on the Environmental Influences Lab, which is Lab 6, as well as Lab 7, which is looking at Vibrio fischeri. That one is a particularly interesting lab, and certainly one in which the lecture has some nuances. So please, if you're signed up to give Lab 7 lecture and you're at all uncertain about the content there, please let me know, and I'll be glad to give that lecture for you. Well, obviously those of you who have me as a supervisor, and of course I'm sure Richard and Jacob would also be willing to take the reins there if needed. Lab 6, on the other hand, is a pretty fun, straightforward lecture with lots of cool pictures and lots of cool action. So that one is one that can be definitely be taken by the horns for anybody who might want to or show interest in that one. I'm going to go ahead and start today by reviewing a couple of things on eCompanion. I just want to call your attention to a few nuances that maybe some of you you're already bored at this point, and some of you have, never done some of this before. So hopefully tune in and it'll be review for some of you, I know. So this is the gradebook feature. So you can see up above I've clicked on gradebook, and I know all of you have done that before. But in order to adjust the pre-lab scores, you're going to come to the drop-down menu and just hit pre-labs here. And then you can hit go. And this will bring up your individual students and their pre-labs. So I'm just going to pull this open without having corresponding student names there. But let's say that your group C, so this is Jesse and Bo's lab, and you need to update your grades for pre-lab 1. So you just click on that, and then you can see that for example, this person earned a 25, which we know is actually 2.5. And then you just enter in like that, 2.5, 2.4, 2.5, okay, this one's a 1.8. And then you just hit Save Changes, and then you've updated the pre-labs so that your students can actually see their scores, and that's super nice for them. I also want to show you another feature on the gradebook. If you click on Setup Gradebook, this will bring you into a spot where you can add assignments. So for example, for everyone, you've turned in the Gram-Stain report at this point. So maybe you want to add it to the gradebook so that you can give the students their score on eCompanion. So we'll go ahead and pop on down, and you're going to say add custom item, and it looks like I just want to make sure nobody's already done this. It doesn't look like anybody has added in the Gram-Stain report yet. So I'm going to go ahead and do that. So you just say Gram-Stain report, and then add. And then you should see this now on it should come up now on the list of assignments. So we can scroll down and see if we can find it here, Gram-Stain report. Click on that, and that makes it a gradable item. So you hit Save Changes. And then you can go on to the next screen. So hit Next. And then you'll just want to select this as a gradable item. So there you can see the Gram-Stain report. We can just put it under Home. So you click on that. And then you say Save Changes. And then you can click on Next. This will now allow you to add the points, the point values for this. So we're going to go ahead and find the point value for Gram-Stain. We know is 15 points in total. So just add that. And then hit Save Changes. And now you should have that fully entered assignment. It should be there. You can now hit save and you can head out into the gradebook and add your Gram-Stain report points. I know that a lot of you are still working on grading those, and that's totally copacetic. One rule of thumb that I use for grading is that if you give your students a week to submit the assignment, you should also give yourself a week to get it graded. Sometimes that works out, and sometimes it doesn't. And always err on the side of quality in grading. So if you know you're not going to have enough time to put into it, don't rush it and do a poor job of grading. Instead, just tell your students, keep in touch with them, use communication well, and say, you know, I'll plan to get those back to you at X and X date. So it's better to do a good job of grading. Okay, let's talk just a little bit more about the TA guidelines for Lab 6 and 7, as well as just a little highlight on Lab 8. So we talked a bit about Lab 6 before, but make sure you do summarize their dilution problem results on the board, because that way it gets them stimulated to get the dilution problems done. Also remind them of the due date for the dilution problems that's written on the board, and make sure that they're aware that they can come and get help from us at any time. There were certainly some students who were there on Friday during open labs, so they're getting started on them. For Lab 6, you're also going to want to be ready to give the demo for this streak, the T-streak. So this is an important, very important technique. So once again, make sure you're reviewing how to teach the method and not just, I know all of you know how to do it, but think about good ways to present that material as well. And my goodness, some of you did such an excellent job on the demonstrations that you did for aseptic pipetting. There was a lot of good work there, but do always remember to, when in doubt, over-explain rather than under-explaining. I often hear a lot of the, well, you know what I mean. Well, they don't, because they haven't taken the class yet. So you guys do know, and you can say that to the other TAs, but it's hard sometimes to resituate yourself in the student's perspective and recall that they really honestly haven't seen any of this material before. So over rather than under explain each step in the T-streaking procedure. Again, we'll then pause, let them do their T-streaking, and then we'll go on to environmental influences. There's some awesome pictures in here and a lot of good tips for giving this lecture. So I know all of you who do the lecture will enjoy that greatly. Okay, I think that's enough for Lab 6, especially since we covered it before. And I'll just talk briefly about Lab 7. And Lab 7, of course, is the lab in which we will be doing the Vibrio Fischeri demonstration, and I generally take the students back to the darkroom for that. So that's not necessarily something that you need to be prepared for, but I would like you, especially if you are giving the lecture, to do a lot of preparation for this one, because there's a lot of content in it. One quick note before I talk more about that is that we will be restreaking the T-streaks as well. So we want to have them pick either a Micrococcus luteus colony, the tiny little yellow one, or we'll have them pick the larger Staph aureus colony, and they're going to restreak with that onto a new T-plate. Don't let them forget to do that. Also, remind them that there are a lot more colonies, or a lot more cells in a colony than there are cells in a loop full of broth. So it's important not to take too much from that colony, or they won't get any kind of isolation at all. So just a couple of notes on the bioluminescence lecture. There's a lot of additional information here, and particularly if you can find the publications by Margaret McFall-Nye. She actually is the main person publishing on this, and there's a nice video also on YouTube that you may want to check out, and sometimes it's even fun to play this video for your students, I think. So we'll be doing that. That will be our lab for Thursday for most of you, or Wednesday or Thursday, depending on which day you have lab. It's also on that day that we're going to turn in the Pipette Man tutorial, so make sure that your students do turn in that tutorial before they leave on that day. So that sometimes is a hard thing to remember, to remind them to get that turned in, but also to make sure that we're doing a good job of helping them with that. Please don't feel like that you would be mistaken to go around and tell them about why they don't want to let the Pipette Man snap up. I want them to think about it, but I also want them to come out of that exercise really knowing why they wouldn't want to use poor technique with that Pipette Man. So definitely do a good job with that. My Gen Micro students are super jazzed about the Winogradsky columns. So after having announced that a number of times, they're all getting mud and water and they're so excited about it. And so, excuse me, I raced today and it was not my best day, but I have a racer's cough, so I apologize. So the Winogradsky columns should be super fun, and I'm hoping we're getting some things together for that, and all will be well, even though a lot of the source waters are frozen at this time. I'm just going to take a moment to go through the Lab 8 TA guidelines just for T and Elia, who will be going on Thursday to this lab. This is a jam-packed, action-filled lab with a lot of setup, a lot of different stations, and in fact it helps a great deal if you can have your students split up. So at the beginning of the lab, say this bench will start with UV irradiation, this bench will start with Kirby-Bauer, this one with streptomycin resistance, and then that way none of your stations become uber congested. This is also a pretty straightforward lecture, but it is long, so it just is a lecture that includes just about everything and really does even go back to some of the conceptual things on wavelengths of light and whatnot. So we will talk about DNA damage via UV light and how repair mechanisms can be induced in bacteria to fix that damage. We'll also talk about antibiotics, and this will be the students' first exposure, in my class at least, antibiotics. We talked a little bit about penicillin and, you know, basic ideas behind it, but we haven't looked at all the individual antibiotics yet. So you'll want to do a very thorough job, a good job, of introducing these to the students for the first time. In terms of the procedure, we'll want to do the UV light and the Kirby-Bauer with confluently inoculated plates. So reminding them that they want to get bacterial growth on every surface of that plate, so really covering the entire thing. For the streptomycin resistance experiment, it's important. This one is important to explain because not only conceptually but also in practice, it is very difficult for students to understand, probably largely because of a cultural misunderstanding about antibiotics, that they don't induce mutations. What we want to help them understand is selective pressure. The idea that when we have an environment that is fraught with an agent that selects, that it pressures those that are already resistant to grow and live and thrive, whereas those who do not have the resistance will die. So it's essentially selecting for the superheroes in the population. And that's the analogy that I usually use, is that the X-Man type analogy where the superhero will live through something that the non-superhero can't survive and gets selected for. So the idea that antibiotics cause mutation, sometimes there's even that idea that antibiotics cause a person to be resistant, and that's completely wrong because obviously the antibiotic is working on the bacterium, not on the person. So there's just a lot of misunderstandings that come with this conceptually. But then also in terms of doing the experiment, it can be confusing to the students that we're doing the same experiment twice. So essentially we're going to have the broth tubes, one with antibiotic, one without, and the plates, one with antibiotic, one without. So it's like a control and the experiment, a control experiment, but we're doing it both in agar and in broth. So trying to explain that to them, or briefly explaining that to them, is never it's never time wasted. Fantastic. So that is going to wrap things up for tonight, and I hope you're all having a marvelous weekend and getting some downtime, and I can't wait to see you soon.